Okay. How you doing, everyone? I'm Glenn Gare, and I teach statistics here at the State University of New York at New Paltz in the Department of Psychology. And this is spring of 2020, which is kind of a crazy semester. And because of that coronavirus thing, we're putting all of our classes into an online format starting after spring break, which starts actually today. So what I decided to do was to video the lectures for the upcoming material, and then I decided, wouldn't it be good to actually video lectures of the entire book and the entire course so that we can have that as a resource that could be used for future students and for future offerings and so forth. So I decided to produce these videos along with our friend Dana Thomas, who is the associate producer, director, and videographer. Thank you, Dana. And we're gonna, for each chapter that I go over in class, which is chapters 1 through 12, I'm gonna do a video. And people who have questions can certainly contact me, especially students who are taking my class now, and that is gonna be the way to, at least for the rest of the semester, communicate. As I tell my students, this book that I wrote with an alum of mine, Sarah Hall, Straightforward Statistics, is completely based exactly on how I teach the class, and a lot of it is like word for word how I say things when I teach the material, things I write on the board. So do get the paperback version of this book is what I strongly recommend, and you'll see that it connects and dovetails really well with how I present the material. So this book and these lectures go very much hand in hand. If you watch the videos carefully, rewind if you get a little confused, read the book carefully, do the homework problems, etc., you will be in great shape. So this particular unit is chapter 1. Chapter 1 is a brief introductory chapter, prelude, titled, Why Do I Need to Know Statistics, or Why Do I Need to Learn Statistics? I've been teaching statistics since 1996, which is probably before you were even born. And I love teaching it, and I will tell you that I didn't really feel like I truly understood statistics well until I taught it to undergraduate students at the University of New Hampshire. And after I had the experience of teaching it, I felt like not only did I understand it, but I came to love it. I've been teaching here at SUNY New Paltz since 2000, and I will say that students tend to be petrified of statistics. So the very beginning of the book are quotes that are the kinds of things I hear. One is, I went into psychology because I want to help people, not to learn a bunch of scientific math stuff. I've heard that before. I majored in psych to avoid classes like this one. I've heard that. I'm not good at math. The percentage of students in my class who say that off the bat is very high, and it's usually not true. I'm scared of this course is pretty common in terms of what I hear as well. What does statistics have to do with psychology anyway? So a lot of times students don't see the relevance. There are 3 big barriers that I've run into with students in this class over the years. Students don't want to learn the material, they're not motivated to. They don't see the material as relevant to their interests, and they tend to be scared of this course. So in combination, stats is something of a challenge to offer. Part of the reason I like teaching it is I love seeing students become not afraid of stats. I love seeing students feel like they can master the material. I love seeing students say, wait a minute, this stuff actually is relevant to my everyday life. There are so many ways that stats is relevant to something you're thinking about every single day. If you're a college student, you might think about different ways of studying. You might have a big exam and you might say, should I spend these 2 hours I have reviewing the textbook, or should I spend these 2 hours reviewing the notes? I'm not quite sure. You might decide, well, I'm gonna do the textbook and see how that goes, and then look at your score. And then the next time you would actually use statistics, you'd probably say to yourself, did I do better or worse than I think I would have done if I had done the other method? You know, that's statistics. We think about correlation all the time, or the relationship between different variables. So you might think about simply the number of hours that you study for an exam. My suggestion to students is think about how much you should study and then double that, by the way. But typically you probably think how much I study is positively related to what my grades are. Simple, right? You don't even think that that's a statistical thing that you're thinking, but it is. And we're thinking about statistical things all the time, implicitly, and and explicitly. Another reason it's important for psychology students to learn about statistics is we're learning about studies and findings all the time, findings in the behavioral sciences. You might learn that, like, let me just try and think. The other day, we did a study and we found that people that are high in the dark triad, people who are narcissistic, people that are manipulative, and people that are psychopathic or don't have feelings for others, when they're asked how much they would help someone, and we had this big helping index, people high in the dark triad score is significantly lower than everyone else in terms of how much they would help other people. So it's as someone who understands stats, you'd be able to look at our findings when we write that up and understand what it means and understand whether you can trust those results, whether those results likely generalize to other scenarios, and so forth. So stats helps you understand stuff in your everyday life, and it also helps you understand the literature and the research in the behavioral sciences. So that's why we make you take stats, and we hope that it provides you with a set of skills that are really useful for your future and for you how you think about pretty much everything. There are two basic things in the first chapter that I want to underscore. And I like to put the question this way. Is this finding I'm going to quote this, big deal? So think about this question, and I'll just put one finding, e.g., this is a Latinism for example. So an example of what I was just talking about. People who scored as narcissistic in my study scored lower on wanting to help others. Okay, this is brand new data. We haven't done too much with it. We haven't published it in an academic journal. We certainly plan to. A lot of times I like to get our ideas also out into the mainstream popular press like Psychology Today and other popular sources, because if our findings don't make it out into the world, I'm of the opinion that it almost doesn't really matter. So this is usually what we'll do with our findings. But this is a study that's still in progress. We just analyzed the other day. We have data from about 300, maybe even 400 undergraduate students from various schools, mostly from SUNY New Paltz. And we have a lot of different findings. This is one of them. People who scored as narcissistic in our new study scored lower on wanting to help others. Based on our finding, is this enough to say that this is a big deal? Are our findings good enough so that I can write up something that I'm going to try to publish publicly for anyone in the world to access with my name on it, with my university's name on it, saying not only is this what we found, but this is probably true in a more general sense? It's kind of a scary thing, right? When you're publishing something and you're saying this is how people are, you're making a big statement and you're putting your name out there. So there's two basic ways that we address this with statistics. So this question, is this finding a big deal? There are two basic ways to address this question. A, we have what we call effect size. Is it a big effect? And I'm quoting big because that's kind of relative, but is it a big effect? So let's think about what would that mean if it's a big effect. I'll put two universes over here. So here we have, I'm going to call this universe universe 1. And I'll call this the big effect universe. And then I'm going to put over here universe 2. The small effect universe. Okay, I'm going to ballpark some numbers. I actually don't have the data on me, but I'm going to give you a sense of what the data might look like. We could divide people based on our narcissism measure into either high narcissists versus people that are low in narcissism, or what I can call low narcissists. And then here we can have the helping score. And we would put the helping score, we're going to learn later in the class about this, but we could put the helping score as what we call a mean. The word mean in statistics means average. I don't know why someone felt the need to come up with a different word for it. They could have just used average. They wanted to use the word mean. So anyways, this is going to be the average. So let's say the helping score index was 0 to 100. This is the big effect universe. In the big effect universe, I'm going to create a big effect here. Let's say that the amount that the high narcissist wanted to help on average was 11.3. And let's say that people who are low in narcissism wanted to help 92.6. Hypothetical numbers I'm putting there, but just to give you, the student, a sense. If you saw this, if you saw not only did the low narcissist score higher on wanting to help, but they scored like 80 something or 90 something points higher on a scale of 0 to 100, and then you asked yourself, is this finding a big deal? What would you say? You'd say, yeah, that's a big deal. It's like I built that in as a huge effect. So that would be what we would call a huge effect size. Later in the semester, in other modules, we're going to get into mathematically computing a big effect and criteria by which we'll call something a big effect versus a medium effect versus a small effect. But I tried to make this one just like, whoa, anyone who sees that is going to see that as a big effect. So one way we can talk about is something a big deal is largely how different are the means from each other, or just how big is the effect. Universe number 2 is the world of a small effect. So here we have high narcissists. And here we have low narcissists. And again, I don't have the data in front of me. I'm not sure which one of these is true in the data, but it doesn't really matter. I'm just using these examples to make a point. So this is the small effect condition. Let's say high narcissists wanted to help 46.3 on a 0 to 100 scale. And let's say the low narcissist wanted to help 47.2 on that same scale. My mom lives in Florida. If I got these data, would I pick up the phone and call my mom in Florida and say, Mom, I found something amazing. I found something worth telling the world about. If the means were just this much different from each other? Probably not, right? This is kind of going back to this question, is this finding a big deal? With this kind of small effect or a small difference between the groups or between the means of the groups, you're more hesitant, right? Anyone looking at that or eyeballing it, so we have that word eyeballing the data. Eyeballing means you're not doing something systematically, you're just looking at it. Anyone who is eyeballing the data would say, whoa, that's a small effect. Who cares, right? That's almost like that tells me almost nothing about differences between people that are narcissistic or not in terms of helping. Whereas this effect, if you just eyeball it, you look at it, and you're like, whoa, that's a huge difference. So one of the ways we talk about whether an effect matters, whether a finding matters, whether a finding is a big deal, is the effect size. And sometimes we can simply look at the effect with our eyes and just eyeball the data and figure out, is that a big effect or a small effect? There's a second way. The second way is a little bit more nuanced. The second way is with something that we will call statistical significance. Statistical significance is something that in this course, chapters, I think it's 6, 7, 8, and 9, all build on the concept of statistical significance. It's kind of counterintuitive, it's kind of abstract. When you get into the nuts and bolts of it, it's actually kind of weird and there's more to it than could be explained quickly, but I'll give you the short version of what statistical significance means. Statistical significance essentially means that the findings or the pattern found in a sample likely, I'm going to underline that 3 times, 3 underlines because that's wicked important. It's a probabilistic judgment, and that's why I'm underscoring this concept of likely. Whether the pattern found in a sample likely generalizes to the broader population of interest. In statistics, we have 2 almost independent ways. Sorry, here I put an A and here I put a 2. The magic of the whiteboard is that's now A and a B. Statistical significance is actually related to effect size, and as we'll learn later chapters, maybe chapters 8 and 9, we're going to get into the relationship between effect size and significance. However, they are conceptually different from one another. You can have a situation where you have a big effect size, but you do not have statistical significance. The details of statistical significance, like I was saying before, include all kinds of mathematical processes that we're going to get into, not today, that we'll get into in one of the more advanced modules. But the real short version is this. If a researcher says we, quote, found statistical significance, that means that they're saying that they have good evidence that the pattern found in the sample likely generalizes to the broader population of interest. Let's go back over here to universe number 1. So here's a study where we're interested in whether people who score as high in narcissism are less likely to help others compared with people who are low in narcissism. If in this study I not only showed you these means, but I also told you that the finding was significant, just assume that for now, and later in the semester we'll talk about how we can figure that out. But let's say the finding was significant. If you hear that phrase, the finding was significant, that means that we found statistical significance. It's the same concept. If you find that the finding was significant, that means not only did we find a big effect size, but we also, through some advanced statistical process, feel confident that we can make this inference. That we can say that pattern with the narcissists helping less than the non-narcissists is likely generalizable to the broader population of interest. Because if I'm doing a study, I don't really care about the 300 or 400 people who I study. And I don't mean that in like a mean or nasty way. What I'm saying is this. When I'm doing a study on a sample, I'm not interested in making inferences about that sample. I'm really interested in making inferences about the broader population. Think about the coronavirus. Imagine if you work at a biotech firm and you have a potential vaccine. And I know that there's several companies all around the world that are working on this right now. Imagine that you found evidence that your vaccine seems to work in a sample of 20 people used in the first human trial. Do you want to make the inference that this vaccine works for those 20 people? Or do you want to make a bigger inference and say, wait a minute, look at this. This vaccine most likely is going to work for human beings in in general. And it's definitely that second point that you're trying to make. So when we're doing research of pretty much any variety, we're studying data from samples, trying to make inferences about broader populations. I'm not really interested in the narcissists and the non-narcissists in my sample. I'm interested in whether our data allow us to understand narcissists in the world in a more general kind of sense. So that's what statistical significance is all about, finding patterns in samples and making inferences to broader populations of interest. And it's different than effect size. They're often related. If you have a really big effect size, you're more likely to get statistical significance, but it's a different comment and a different process. The homework problems from chapter 1 will give you a bunch of different kinds of examples from researchers, and you're supposed to figure out, is that researcher commenting on effect size, or is that researcher commenting on statistical significance? If the researcher says there was a big difference between the groups, that researcher is talking about effect size. If that researcher says the findings likely generalized to the broader population, it's unlikely to have come about by chance. Once you hear that probabilistic language, they're talking about statistical significance. So effect size and statistical significance are two of the 4 big concepts from this first chapter. The other 2 are related to effect size and significance. So in this course, there are several chapters, and the chapters deal with 2 basic kinds of stats. So there's 2 basic kinds of stats. And the way it works in the course, in the textbook, and in these modules, the beginning part of this course is all about what we call descriptive stats. Descriptive stats or descriptive statistics. Descriptive statistics are exactly what you would think they are. Their point is to describe patterns of variables or relationships among variables. So if I did my study before and I was interested in the helping variable, so I'm going to put EG as an example. Let's say that the helping variable went from 1 to 100. Let's say that was the range. Let's say the mean across all the participants was 48. I could also talk about how much the scores varied from each other. I could talk about the highest score versus the lowest score. There's a bunch of things that I could talk about that one variable. Which values were most representative, what was the most common score, what was the second most common score, and so forth. So that's describing a single variable. Sometimes I can describe relationships between 2 variables. A classic thing would be a correlation. So let's say that you did a study and you wanted to see if students who studied more time scored higher on the exam. That would be a relationship among 2 variables, studying time and exam score. If you are not making inferences about a population and you're just looking at the relationships between those variables, that fits under what we call descriptive statistics. The first half of this class is largely about descriptive statistics. The second half of this class is largely about what we call inferential statistics. Inferential statistics is all about statistical significance. So the core or the root of the word inferential is infer, and it has a really specific meaning. So inferential statistics are a variety of stats that allow us to ask this question. Can we infer that the pattern found in a sample likely generalizes to the broader population? And if you take a look at the definition of statistical significance we put up before, which is when we're talking about the pattern, if the pattern found in a sample likely generalizes to the broader population of interest, you can see that inferential statistics and statistical significance go hand in hand. So the inference that you're making with inferential statistics is an inference about statistical significance. And an inference about statistical significance is an inference about whether whatever you found in your sample is likely to generalize to the broader population. So there's two basic kinds of statistics that we're going to go over in this class. Descriptive statistics that are just about describing single variables and relationships among variables. Then we're going to move into inferential statistics, which is all about whether the findings that you have with your sample are likely to generalize to the broader population. That's chapter 1, and that is Stats with Glenn.